We have finally made it to the only type of inequality that we do differently from an equation. All the other inequalities we've done so far, we treat just like an equations. Now we're to the one situation where we're going to do something different, and that's when we multiply or divide both sides by a negative sign. This will of course be implying from Module 4, Lesson 7, which says solve one-step multiplication and division inequalities with negative coefficients. According to the lesson guide, this one's going to end up taking us about 2 days, so they say. Yesterday's was really quick, but let's get started and see where it's going to take us today. Isaac is responsible for tracking the inventory of dog food at a warehouse. The inventory of a certain brand of dog food is currently 780 bags and is reduced by an average of 35 bags of food per week. Isaac needs to order more dog food when there is fewer than 250 bags left. Isaac has a very big dog. From here, the integer negative 35 represents the change in the number of bags of food each week. The integer negative 530 represents the change in the total of inventory when Isaac needs to reorder more dog food. The inequality negative 35w is less than 530 can be used to represent the situation, where w is going to be the number of weeks. Think of a possible solution to the inequality. Is it a true statement when you substitute the value of an inequality? Why or why not? These are the things we're going to be learning about in today's lesson. The inquiry question for today's lesson asks, how does multiplying or dividing each side of an inequality by the same negative number affect the inequality? Well, let's find out. Suppose you were given the equation 4 equals 4, and you multiply or divide each side of the equation by the same negative number. Do the sides remain the same? Be prepared to justify your answer and so on. So here we have 4 over 4. If we were to multiply it by negative 3, the sign stays the same. So if I was to take and reset that, and I was to take and divide it by negative 2, the signs stay the same. Well, I say the sign, that means the equal sign right here stays the same. But everything else, well, those two things became negatives when they were positive. But when you do whatever you do to one side of the equation, gives you the same exact thing on the other side of the equation. However, if you're dividing or multiplying both sides by a negative, you're going to flip the sign. So where we had positives, now we're going to have negatives. The next thing we're going to do is we're going to take this graph and we're going to create an inequality to it. So I'm going to take this 4 and I'm going to change it to become, let's do 8 right here. And you can see now that 8 is greater than 4. Where I had an equal sign, I now have a greater than sign. What happens if I divide these two by negative 2 though? If I did that, watch what happened. Boop! That sign just changed directions. So now I have the number on the left is going to be smaller than the number on the right. Well, let's reset that. Let's go back up here to 8 again. And this time I'm going to multiply both sides by negative 3. And whoops, when I do that, what's going to happen? Well, once again, that sign changed directions. And that shows you the only difference between working with equations and working with inequalities. If you multiply and divide both sides by a negative sign, the sign changes directions. Everything else is the same. Nothing else is different. That's the one difference. Multiply or divide both sides by a negative, boop, you flip the inequality sign. That's all there is to it. Now we're going to take and continue our study into the division and multiplications property of an inequality. We talked about this the other day, and we're going to take it even further now because now we're looking at it when it has a negative number involved. When we looked at this before, all we had was a positive number. Well, that didn't highlight very well. Let's try that again. All we had was a positive number. Now we're going to look at the rule with a negative number. So first thing is it says that when you divide or multiply both sides of an inequality by the same negative number, the inequality symbol must be reversed for the inequality to remain true. Looking at that with symbols, if A is less than B, then A divided by C is going to be greater than B divided by C, if where C is less than 0, meaning it's a negative sign. And if we look at that in numbers, well, you can see right here, anytime you multiply and divide both sides of an inequality by a negative number, the signs are going to change directions. Let's watch this animation on how they say to do it.
What happens when you divide each side of an inequality by the same negative number? To find out, start by graphing each side of a numerical inequality, such as -6 is less than 4. The number line shows that the inequality is true because -6 is to the left of 4. Next, divide each side of the inequality by a negative number, such as -2. Then simplify each side. To check whether the new inequality is true, graph each side. The new number line shows that the new inequality is not true because 3 is to the right of -2. So 3 is greater than, not less than, -2. To make the new inequality true, reverse the inequality symbol. This pattern is true whenever you divide each side of an inequality by a negative number. You must reverse the inequality symbol to keep the inequality true.
Now that did a really good job of explaining why it works the way it does. Let's see if we can apply that to some real problems. Example 1 says that -2x is less than 10, and they want us to solve it, check the solution, and then graph the solution on the number line. So, for the solving it side of it, we're going to treat it just like an equation, and that we're going to divide both sides by -2. But do you see what happened right here? Let's zoom in right there. See this sign? That sign flipped. It changed directions. The reason it changed directions is because we divided both sides by a negative number. So from here, -2 divided by -2 is a +1. +1 times x is going to be x. +10 divided by -2 is going to be a -5. So our final answer, x is going to be greater than -5. And that's all there is to doing that. I mean, it's super simple, guys. Works just like the equations. Only thing now is that we're dividing by a negative sign, so the sign's going to flip. You take a moment. Actually, let me see if there's anything else we need here. Yes, to graph it. We've already talked about how doing that. See if it's going to work. It's going to be an open circle. We're on the -5, but my open circle, my -5. Nope, it does not appear to want to work here. Oh, there it was. I got it. And then, actually, let me go back and see. X is greater than it. Now I figured out how to work this. So we're going to start at the -5, and we're going to drag to the greater than sign, just like that. Check your answer, and the answer checks. Nothing to do in these. Now it's going to be time for you guys to pause the video and work on extra example 1 to see if you know how to do it too. So our new problem says -2.5y is greater than or equal to a -8. Now I'm going to do it a little bit differently from how the textbook did. I'm just going to take and do my division just like this. -2.5, -2.5. And then as far as flipping the sign goes, I'm going to do that in my next line. Of course, these divide out to be 1. 1 times y is y. Those negatives divide out. And now all I have to do is take and divide 8 by 2.5. To do that, I'm going to bounce the decimal outside the house until I hit the wall. I'm going to bounce the decimal inside the house, the same number of places to the right, and annex a 0 is needed. 25 goes into 80 3 times, which is 75. 5 left over. Annex in a 0 and bring it down. 25 goes into 52 times with the decimal coming up, and 2 times 25 is 50 with nothing left over. So our answer would be y is now going to be less than 3.2. When we graph it on the number line at our positive 3.2, we're going to have a solid circle because it's an or equal to, and the arrow goes to the left. When we go back to our answer key, we're going to put in the less than or equal to 3.2, check it, and the answer checks. That's all there is to it. Example number 2 says x divided by -4 is greater than or equal to a +3. And we're going to work this one, once again, just like we would work any other equation. So you start off by writing the problem. Next thing you're going to do is you're going to undo divided by -4 by multiplying -4 on both sides. Now, as I usually tell you, I would always take and put that times -4 you see here, I'd put it after the number I'm doing it to, not before it. From there, these -4's divide each other out, leaving x all by its wee little lonesome. Oh, wait a minute. Nope, we got to change the x over to this side because no, we don't. I'm sorry, because they already flipped the sign right here. Notice when they divided or multiplied by -4 on both sides, the sign flipped. So that's going to be x. Then over here, -4 times a +3 is going to give us a -12. Check it, and the answer checks. It really is that simple to do these things. Now you get one more practice problem to work on, and that's going to end up being extra example 2. Do that one real quick on your paper. Make sure you're showing good quality supporting work, and then check your answer. Alright, my problem says a divided by -1.2 is greater than a -4. The variables a, his friend is -1.2, and -1.2 is dividing a. So to make that -1.2 go away, we're going to have to take and multiply a -1.2 on both sides. Now I'm going to do it after it, like I have taught you guys to do. I'm also going to make sure that it's above the middle, at least in the middle, if not on top here. You never want to put that times 1.2 in the bottom. And now my sign is going to change directions. It's changing directions because I am multiplying both sides by a negative. Here, these are going to divide out, becoming 1. 1 times a is less than 4 times 1.2. Well, that's going to end up being 4.8, and negative times a negative is going to be a positive. So your final answer is going to be a is less than 4. Oops, I have to put a 2 there. That should be a 4.8. Come back over to where we can check it. A is less than positive 4.8. Check, and the answer checks. Really is that simple to work these problems. That's it for our lesson today. Get started on your homework assignment and let me know if you have any questions when you get to class tomorrow.